See Standard 12th Maths, Chapter 2, Complex Numbers, Exercise 2.7. See, before start doing the problems from this exercise, let me give you some introduction. Usually the complex numbers are represented in the form x plus iy, where x is the real part of the complex number and y is the imaginary part of the complex number z. The same complex number we can represent in the polar form, that is in terms of r and theta. R into cos theta plus I sin theta. See, where r is called the modulus or the absolute value. We say the absolute value or modulus of z. So we get r is equal to square root of real square plus imaginary value square. We represent r as modulus z. And theta is called as the argument or amplitude of z. So this theta is equal to argument of z. We represent this. See, how do you get this theta value? Theta is equal to tan inverse of bar y by x. Y by x. Tan inverse of y by x. That is tan theta is equal to y by x. Imaginary value divided by the real value. See, what about the value of theta? See, in case 1, theta can have many possible values. Many possible values. See, just by adding 2 pi by adding multiple of 2 pi. To this theta. In the second case, this theta has unique values. That is, this theta ranges between the interval pi to minus pi. But here, it may be equal to also. See, minus pi strictly less than theta, less than or equal to pi. See, why we are not considering equal to this minus pi is here. See, in the complex plane here, see, this is real value, imaginary values. See, when you measure the angle, we start from here 0 degree, 90, pi, and then here 270, 360. I stop here pi, and then this is anti-clockwise direction. Give the clockwise rotation here. I again start in the negative direction. So in that case, the angle is minus pi. Usually we take this in this way only in the complex number. See, in the first case 0 to pi, I include pi value in the last value. But here in the clockwise direction 0, here this to minus pi, just limit touches here the pi. So we are not give the equal to minus pi here. Okay. Next, let us see one more concept. See, the unique value of theta, the principal, we call this value as theta as the principal value of of theta, or we say that principal argument of z, principal argument of z. Usually this principal argument of z is represented with capital ARG of z. So that lies between minus pi, strictly less than minus pi and less than or equal to pi. So this theta is ranges here pi to strictly minus pi here. So how do you get this argument z? Actually I said argument this z is the unique value. So this theta is represented in the small argument, has many values by adding the multiple of 2 pi with this angle theta. Now let us see the principal argument condition. In the first condition, here it lies in the first quadrant. Here, let me have the quadrant here. X-axis, x dash, y-axis, y dash. So this is your first quadrant, this is your second quadrant. So let me take a point P here, so joined with the origin. So this line makes an angle, let me mark it as alpha. Make it an angle alpha with the x-axis in the anti-clockwise direction. So in the first quadrant, this theta or argument theta is equal to the angle made by the line with the x-axis in the anti-clockwise direction. Same thing, let me take in the second quadrant, third quadrant. In the fourth quadrant, let me take the image of this line. So here alpha means the image of this angle is minus alpha. So in the fourth quadrant, here a theta argument takes the value minus alpha. Now let us see the second and third quadrant angle. So when I take the same line in the second quadrant, here origin. So here the angle point P here. So the angle made by the line with the x-axis, here is alpha. But argument theta is here. The angle measured from the x-axis in the anti-clockwise direction. So how do you take the value of theta here? So here is alpha, but I need to get this theta. See, the whole straight line angle is pi. So from this I subtract this alpha. So this is your second quadrant argument unique value. So I take theta is equal to pi minus alpha. This line image lies in the third quadrant. So in that case I need to measure the angle theta here with a clockwise direction, negative direction. So this is your alpha here. So in that case the image of this line lies in the third quadrant. The image of the line in the second quadrant lies in the third quadrant. So therefore it will be the negative of the angle in the second quadrant, minus pi minus alpha. So minus into minus plus alpha minus pi. So we take the third quadrant angle as alpha minus pi. The second quadrant theta is equal to pi minus alpha. So this is the important point here for you. So all this argument, principal value or principal argument is a unique value. When you take in the first quadrant, theta is alpha, and fourth quadrant, theta is minus alpha. In the second quadrant, theta is equal to pi minus alpha. But in the third quadrant, theta is minus of this, alpha minus pi. So therefore, our argument z, we get it from principal argument is, argument z is a unique value. With that, if I add 2n pi, I'll get our argument z. So n is in z. So that using this, let me do the sum from the exercise. First, see the first sum, write in polar form of the following complex number 2 plus i2 root 3. See, first write in this, actually let me take the complex number as z, 2 plus i2 root 3. See, in the Cartesian form it is x plus iy. In the polar form, if I write, this is r into cos theta plus I sin theta. So you are going to represent in this Rn in terms of r and theta form. So first I have to get what is r. R is equal to square root of x square plus y square. That is square root of x squared. Here is 2 square plus imaginary value, y value is here 2 root 3 square. So 2 square is 4 plus 2 square 4, 4 3s are 12, square root of 16. That is equal to 4. That is equal to 4. First let us find the angle made by this line. Actually, you have to see the position of the in which quadrant this point lies here. See, first quadrant, second quadrant or third quadrant. X axis, y axis, x dash, y dash. This is positive, negative side here, positive, negative here. So where this point lies here, 2 plus, both are positive. X value is positive and y is also positive. So it is in the first quadrant. It is in the first quadrant here. So therefore the angle made by this line with the x-axis is alpha. So what is alpha here? Tan inverse of y by x, modulus of y by x. Y value is 2 root 3 divided by 2. That is tan inverse of 2 cancel, modulus root 3. So when do you get root 3 value for tan 60? Tan 60 is pi by 3 is equal to root 3. So pi by 3, take tan to the other side, you will get tan inverse of root 3. So therefore pi by 3. So alpha value is equal to pi by 3. Since it is in the first quadrant, what is our argument? Theta is equal to alpha. So theta is equal to alpha, that is equal to pi by 3. So I write the complex number 2 plus I 2 root 3 is equal to r is 4 cos pi by 3 plus I sin pi by 3. Let me do the second sum, 3 minus I root 3. Take this complex number. So z is equal to 3 minus I root 3. That is x plus iy. First let us find the position of this point here. Actually, positive value, positive, negative and negative value. So 3 is positive, real value is positive value, but the imaginary value is negative here. So x is positive, y is negative here. So where this point lies here, it is in the fourth quadrant. This point lies in the fourth quadrant. Let me have here somewhere here. So this point line makes an angle here. This is, will take always minus alpha. It is in the fourth quadrant. Okay, first find r. Is it equal to r cos theta plus I sin theta. So r is equal to root of x value is 3 but y value is minus root 3 square. 3 is squared is 9, root 3 squared is 3, square root of 12. So 4 3s are 12, just you write in the mixed surd form. 4 3s are 12, square root of 4 is 2, 2 root 3. So what is our alpha here? The angle made by the line with the x-axis alpha is tan inverse of modulus y by x. So tan inverse of y value here is minus root 3. X value is here 3. So tan inverse of, we take always positive value. 3 I can write as root 3 into root 3. 1 root 3 gets cancelled, 1 by root 3. So tan value will get 1 by root 3. Tan of 30. Tan 30 is pi by 6 equal to 1 by root 3. So pi by 6 is tan inverse of 1 by root 3. So therefore our alpha is equal to pi by 6. See, the point lies in the point lies in the fourth quadrant. In the fourth quadrant, therefore our theta, you have to find theta. Theta is equal to minus alpha, that is minus pi by 6. So therefore a complex number I root 3 is equal to, what is our r? R is 2 root 3 cos of theta is minus pi by 6 plus I sin minus pi by 6. So here see, I want to mention you here, the point lies in the first quadrant. The point lies in the first quadrant. First quadrant. See, I hope people can understand the concept of this representing in the polar form. Let me do the third and the fourth in the another video. Thank you.